In section 8.1, we are starting our work with quadratic functions, which is just a function of degree 2. Just means that x to the second is the highest power on any of the uh, x variables in that function. Every time we make a graph of one of these, it's always going to follow this U shape that's called a parabola. One thing to note about those is that they're always symmetrical down the middle. The left half and the right half are going to be the same. Um, that line down the middle we call the axis of symmetry, and it passes through the vertex, which is the point right at either the bottom or the top, that middle spot on the parabola. Um, it will either be a maximum or minimum depending on if your parabola is downwards facing or upwards facing. First thing that we'll be doing with these quadratic graphs is we're going to be identifying the characteristics of these graphs. So we'll be identifying the where is the vertex and the axis of symmetry. We'll be identifying the regions where the graph is decreasing and where it's increasing. You can see from this graph, as I read left to right, always left to right, I can see that this graph is decreasing. It's going down on the left side, and it's increasing or going up on the right side. The vertex we'll just be writing as a point. The axis of symmetry is a vertical line, so we'll write that as x equals and whatever the x value of that line is. And then we'll also identify domain and range. Domain for quadratic functions is all real numbers. There are not going to be any restrictions on our domain, but our range, because we have a minimum or maximum value, we'll be able to say there are some y values that do not work. For example, this one here, the range would be everything this point or higher. This graph never goes below this point here. So let's take a look at doing a couple of those. On the bottom at page 248, looking at these two graphs, if I want to identify the vertex of number 1, I'm just finding that point at the very bottom. So I can see that that is at -1, 1. So just write that spot as a point. The axis of symmetry is this line right here. It cuts through the middle of that parabola, and it crosses the x-axis at -1, so that equation for that line is x equals -1. Whatever your vertex x-coordinate is, that's always the value for the axis of symmetry. So if these two don't match, that means that something is off. Which side of this graph is increasing? It's increasing here on the right side. That's my increasing side. So for that, that's everything to the right of x equals -1, so it's x greater than 1. And this graph is decreasing on the left side here as I read left to right. It's going down on the left of -1, so at x is less than -1. So we're using that same x value from the vertex all the way through. As I mentioned before, domain is always all real numbers. And the range here, this graph points upwards. So that is my bottom y value at 1. So that means that I never go below 1. So every y value is greater than or equal to 1. Go ahead and try number 2 and pause your video and give it a shot, and then we'll talk about it. So for number 2 here, I can see the vertex is at this point 3, 4. The axis of symmetry is this line x equals 3. Because this is a downward facing parabola, we're increasing as we move up on the left side. So that's everything when x is less than 3. And we're decreasing once we get greater than 3. Again, all real numbers for the domain. And here the range is everything at or below 4. So the range is y is less than or equal to 4. The next thing that we'll do in this section is we'll be looking at making graphs of um, parabolas. We'll also be comparing them to the standard, the parent function, which is y equals just plain old x to the second. So we'll hit that in the next video. Thanks.